Welcome to the Global Connection, a Tel Aviv University podcast. Journey with us as we discover how TAU's academic community and friends are engaging with and helping to shape this ever-changing world.
Hey everyone, I'm Dana Pousty, a water disinfection scientist and environmental entrepreneur. Currently completing my PhD focused on water disinfection technologies at Water Energy Lab, or WeLab, here at Tel Aviv University. I'm also the co-founder of Solid, an impact venture aiming to bring developed water disinfection technologies to the undeveloped world. Today, I'm thrilled to introduce a guest who stands as a significant inspiration to me. She is a kind and honest woman pursuing her dreams, advocating for justice and social equality, and whose life goals are helping to environment and creating greater access to clean water. Please welcome Tel Aviv University's Professor Hadas Mamane, the head of Environmental Engineering Department here, as well as the head of Environmental Engineering Master's Program at TAU, which is now being offered in English. Hadas is also the leader of the lab where I work and my partner at Solid. Hello, Hadas.
Hi, hello.
Hey. So let's dive in for the first question. Now, before we talk about the type of work we do in WeLab, can you tell everyone a bit about your academic journey? How did you become interested in researching water technologies, and how did it lead to establish the WeLab at TAU?
Okay, thank you, Dana. So I must say that my work on water technologies is first very emotional. When I did my master studies in environmental engineering, I remember that we had a lecture with the professor that he showed us fish that are dying due to water that is contaminated with toxins. I remember feeling that the fish are probably suffocating and how it impacted their, I don't know if to say well-being, but I was very emotional about it. And that is the moment that I knew that my goal is to purify water for humans and for animals and for all living entities on the world. I think that was the most defining moment for me. But I would say that in addition, my father is a professor in air pollution, and I've been going with him to the university since I was a small child. So the world of research was always very fascinating for me, and that was a natural connection.
Wow. Yeah, I didn't know the first story. That's interesting. Can you give the listeners an overview of the type of research we do at the WeLab?
Sure. So I can actually divide our work to three main categories. One is water. The other one is wastewater, and then also waste in general. Within water, what we're doing is a few things. First, we're developing technologies in the lab, and these technologies are supposed to improve the water quality. For example, we are, and we will talk about this later, but we're also disinfecting water in order to kill microbes from the water. And we know that actually the second leading cause of diarrhea in children below the age of 5 is due to probably contaminated water. So therefore, safe water is something that is very important. And unfortunately, this is not the, I would say there are too many people in the world, more than 2 billion people that suffer from unsafe water. So one of our targets is to purify water, but not only from microbes, but also from contaminants, chemical contaminants in water. So for example, pesticides and drugs and all these chemicals that impact the water quality. We're also working on water quality monitoring, and we're working also on connecting between water measurements to AI, trying to predict water quality issues. On the world of wastewater, we're working into understanding the water quality in wastewater reservoirs. We're developing technologies to enhance the reusability of water as a resource. And in terms of waste, we are trying to adapt the technologies that we developed in water in order to actually degrade contaminants from waste. We're also repurposing waste to generate products such as nanocellulose. We're also working on textile waste. So I think this is the areas that we're working in the lab.
Yeah, definitely. and many more, I have to say. Can you talk a bit about the various technologies we use as part of our research?
Yes. So basically, most of the technologies are the combination of photon, advanced oxidation, photocatalysis, new materials, and we're trying to combine all of these technologies. But the idea is also not only to use these technologies, because we are interested in technology adoption in complex settings. I would say that publishing work or research that is related to technology development is one thing. But then trying to develop technologies that have a lower carbon footprint or trying to develop technologies that use less energy is something that is very important because our resources are limited and we really need to consider the atmosphere that we're living in. We know that we have less water. We know that energy can become more is something that results in release of greenhouse gases. We know all those challenges that we have that impact our climate. And we need to really consider these things on technology adoption. So this is something that I would say is very important on technology development. So when we develop technologies, we start with the concepts. Actually, we start before that. We start with an idea. Then we develop the concept. Then we try to implement the idea in the lab in a small scale. And because we're engineers, we increase always the scales always a little bit. So we go to larger scales. Then we try to submit grants to actually implement our technologies together with water authorities or with wastewater treatment plants, desalination plants. For example, now we have a technology, we're developing a technology to extract lithium from the concentrate of desalination plants. So we're going through steps. And ideally, the step that would be like, showing that we really made it is implementing in real case scenarios. And this is very complex because, as we know, technologies are not only the technology, it's also a lot around that.
Yeah, it's very diverse. And how would you say these technology and research approaches are interconnected?
Wow. Well, in the philosophical way, everything is connected. But maybe I would say that that the steps towards developing a technology, but it's not only the physical emphasis of the technology, but it's also, I would think that in terms of environmental engineering, it's really important to develop technologies that can help the world. So our idea is not, to develop like a cellular phone or something like that. We really want to develop things that could impact people that are from low-income communities. And so the connection for us is, again, starting from the lab, but really going to the field and going to complex places where we maybe can learn how to develop a system, how to implement them, and then adoption. So all of these issues are very important, and that is basically I would think the main connection.
Yeah, definitely.
Can I ask you also a question?
Sure. Sure.
So, of course, our focus is on UV LEDs, and maybe you'll just say a word what LED is. Is really important aspect of the work that we do in the WE Lab. And this is something you focus on, Dana. Why don't you share the story of how you became a part of the lab?
Oh, wow. Okay. Yeah. So during my bachelor degree, so first I understand that I want to work like in the environment aspect and ever since I remember myself, like water was so fascinating for me. So when I was during my bachelor degree, I understand that there is a lab, a DAS lab in Tel Aviv University, and it was my goal, like to reach to this lab, and then I just like text you and emailed you, and then we met, and I got an interview by you and Vered, and with Vered as well. And I think that the rest is history, because I did also my master degree in your lab, and then I felt like that your vision and your inspiration, it's a good place and for me to grow, and that's why I also want to stay and continue with my PhD studying in this lab. Yeah.
So maybe I would add that I'm actually inspired by the students, and it's a teamwork. It's never like I think that what makes a lab is mainly the students and the atmosphere, and that you're willing to help each other. So I would say that this is something critical. And this actually leads me to the next question. So can you walk the listeners through a typical day in the lab, how it looks like for you?
Okay, so first of all, there is no typical day in the lab. Like every day is different. What I did like in September, during September, it's not what I will do like next month. So first there is, of course, the wet work in the lab. I'm working with the microbes, bacteria, viruses. So a day of experiment, it's it's a day that I'm fully working in the lab. There are, of course, like some days that I need to analyze the data, working in front of the computer. First of all, I think that in the lab, it's a typical day. It's, first of all, you're not alone. There, like all my friends are there. We have a coffee breaks. We have lab meetings, and these kinds of stuff. And I think that it's very up to your project, because I had a great opportunity during my PhD to travel to India for research and Uganda for research, and the US for research, and also Canada. Yeah, so I was blessed with these kinds of opportunities, and I don't think that like all the labs in the world have those kinds of opportunity to do research in really remote areas and places. So it's a kind of bonus to work in this lab. Yeah.
Thank you. So I think also depends on the students that they're brave to jump into these complex problems and really, go to unknown places. It's part of the character of, I think, of the students as well. So that's great. And what are you hoping to achieve with your research?
First, impact. I want, I like this is the main thing, to achieve some impact, to do some work that other people can build other work on my work, and to do something different. I think that every like research student come to lab or wants to work and creating new knowledge, creating something new, and basically that's it.
Great. Okay, I'm happy about it. I have a question. Well, you mentioned solid in the introduction. And maybe you can share our story on how we moved from research to creating this startup initiative, and what is it about Solid?
Okay, so I think that Hadas and I were shared a same mission and I got a lot of energy with Hadas Lab. And when I understand that I have a place in the lab, first of all, to say my voice, to talk about my passion with Hadas. So during those talks, both of us understand that we want to take this technology outside from the lab. We want to do some impact. We want to change lives. And that's what Solid is about, to access safe drinking water all around the globe, especially for rural areas and for people that really need it. So during the years of the research, together with other brilliant researchers in the lab, we develop a method how to disinfect the water and how to achieve higher inactivation, killing rate, in a simple word, of bacteria and viruses. And also with all the knowledge that we during the research, we understand what is the best solution for each place, how we can integrate and maintain systems in those areas. Do you want to add a couple words about that?
Yeah, I mean, maybe I think I touch upon what you said is that these projects are not the same. So every place where we develop a project on water disinfection using LEDs, which is light emitting diodes, each project is different. Sometimes we work on community water, sometimes on tap water, sometimes we work on the household level. In other places, we work on this technology or that. And the idea is, I think, is how to develop the methods and the tools to really try to understand, and not only that, but also look at behavior, how behavior and technology actually interact and impact each other.
Yeah.
So I would like to ask, what would you say has been your biggest lesson that you've learned?
Wow. I think there are tons of lessons, but I think that the most important thing is that failures is part of success. The first time that we install systems in Uganda, it was a big failure, and then I understand and in every aspect in the research, also in lab work, when I did some research in the lab. So first of all, I know that the first and second experiment will be ruined. I don't know why, I don't know how, but something will happen. And after that, we are learned from our failures. So yeah. The clouds go away and the skies are clear and everything. Yeah.
Now, some people say that there's no failure; it's just a step in the way.
Exactly. I totally agree with that. That's lead me that I would love to ask you the same. What are some of the biggest lessons you have learned while working in environment engineering, and especially in water and wastewater sustainability?
Wow, so this is a huge question. I think that one of the things that I've learned is that, first, not everyone is passionate about these things. I also learned that although for me, taking care of the environment is like our basic need. It's just like breathing air. It's like drinking water. It's like it's our most basic need, the environment. But not everyone thinks this way. Not everyone has the intention to treat the environment. Some people say that they're green, but they don't really mean it, or they're not putting the intent into that. So I think that I learned along the way is that that you need to choose your who's your team to work with, because not everyone will have the same intent. And I think that environmental engineers or environmental scientists, we're like special people that what we really care is how to save the world from ourselves, basically, because we are the reason that we are those that impacted the environment for the bad. And we have an obligation to take care of the environment, not only for us, but also for the next generation. And if we don't do that, and if we live as though life is all normal, and we don't put in effort, and always like there's a reason not taking care of the environment. Now this happened, that happened. There are more important reasons. It's not economic. Whatever the reason is, it's always like on the backside. And I wish that really, truly, in a true sense of way, the environment would be in the front. In the front for people to actually care and take care of an environment. So I think that I learned that not everyone has the same intent, but I also learned that there are enough people that are really passionate about making a change. And these are the people that I mostly associate with, and it inspires me. It gives me energy, because sometimes I just think about, that like half of the population in 2030 will suffer from droughts. Half of the world population, at least a month a year. And when I think about it, I just get depressed. But then when I see like the students and our and how I just get inspired by just coming to the lab and getting to associate with all of you. It inspires me.
Yeah, and I think that like all the students in the lab are really passionate about environment. It's in their blood. Like everyone recycle, everyone like their research is like in their heart. So yeah, it's something very special in my opinion. So what are you think that the biggest challenges in engineering sustainable clean water technologies?
So I think that we have technologies there. Okay. I think one of the challenges is not necessarily the development of the technology, but the implementation of the technologies. And I would also hope that in terms of research as a scientist, I see myself as a practical scientist because I want to implement the technologies and not stay in the lab. And there are not enough sometimes funds to apply technologies in these settings. They don't always consider it as research. They don't consider it as basic research, obviously, sometimes not even as practical research, and sometimes like, what is the control system when you implement a technology in a low-income setting? So these questions are also there. In addition to that, I think that we have to work with people from other disciplines, working with our collaboration from social sciences, public policy, psychology, economics, and without working together with the different disciplines, we cannot make an impact and a change. And I think that this is also a challenge because we speak different languages. Although we speak the same language, we have different languages, and I think that also the economics of these projects. So we all know that people do not have safe water, but the customer is not the person that can pay for the water in these settings. So this is a huge challenge.
Yeah, definitely. Would you say these challenges are really something we collaborate on with others from around the world? What sort of global academic community would you say we are a part of?
I think that we're a part of a community of people that cares about water. That for us, water is everything. It's not just that we drink it, but we feel it. It's as you said, it's us. In addition to that, we're working with an international organization that is called IUVA, which is the International UV Organization. And we have their passionate people that all of them are actually trying to use UV as a disinfection technology to save people's lives. Specifically, we are focusing on light-emitting diodes, but we are really a community that our goal is that the situation of people drinking unsafe water will be a situation of the past. And looking at cyber security and virtual reality, you have all these amazing technologies, but still people die from drinking water that has pathogens inside. This is crazy.
Yeah.
This should never happen. And unfortunately, this is the case.
It's insane that on our planet Earth, we have some people that suffer from unsafe drinking water, and some people that they have like autonomous cars and these kinds of stuff.
Yeah.
Now the lab has also done a lot of field work, particularly in rural areas of Punjab in India. Could you share some of the achievement from your work there?
Yes. So in terms of working with wastewater, one of the things that happens in rural places is that they don't have a centralized wastewater treatment plant. So the wastewater flows from the household through gravity to a pond. And usually this pond, in many cases, it doesn't have a liner, and the water is used to irrigate the crops, especially in times where they need mostly the water. In addition to that, what happens is due to the climate crisis, the patterns of the monsoon change. So people have less and less water, and therefore they are pumping water in lower elevations, and that requires more energy. And that requires more money, and buying pumps that are more expensive. And so people suffer from these climate crises, floods, lack of water, change in the monsoon patterns, all these things, and this impacts the livelihood of farmers. There are cases where farmers commit suicide due to the climate crisis and due to the lack of water. And therefore, in this project, what we're trying to do is we're trying to collect the water, the wastewater, and the storm water, and the runoff water, to treat it in a simple way that will allow using this water for agriculture irrigation. We're also trying to do mapping using different technologies, and we're trying to map the ponds, their size, their quality. We're also trying to use this water for agriculture irrigation, even combining with drip irrigation systems, which is, of course, a challenge because the water quality is lower and therefore these drip irrigations can clog. So we're working on all these areas to combine monitoring, treatment, AI, and also and data science and analysis, and also training students to work in the field. So it's really an amazing project, and hopefully we will be able to connect it to schemes that are related to wastewater treatment and enhancing the reuse of wastewater as a water source.
Wow, amazing! Like
Thank
in
you.
Israel, we reuse water, like and in other places it's not so common. So Hadas, you have I think in the last 5 or maybe more years, every once in a while you're flying to India with your family as well for research. What are some of your favorite memories for working in India?
Oh wow, I have many. So yes, every year I go to India for a few months, and this is because I have a lot of research there. I'm mostly hosted in IT Madras, where I'm also an adjunct professor there. And I think my most memorable thing is that I feel they're at home. In addition to that, I like the spirituality of India. I like, for example, that professors can be on one side a professor working in engineering and sciences, and on the other side, they can be spiritual and express their spirituality. And for them, it's not like it's not like different things. It's being part of a whole and complete human being, and I really like that.
Wow, that's led me to the last questions. What would you say you are most proud of regarding your research so far?
Wow, that's a huge question. I think that I'm proud that I went with my dreams, and it wasn't always easy. I didn't always believe that I can make it. just a personal thing. I have ADHD. So for me, it was difficult to study at school. I didn't finish high school like everyone else. I never believed in my capabilities to be something. And for me, from that point, becoming a professor is something that I always try to make people think that you can reach the skies if you really believe in it. And I think that this is my most important, proud that you have to believe in what you want to do in life and go for it. And yeah, I guess I'm proud of it. Yeah. And I'm proud of my students and teaching students to love the environment. So, yeah.
Yeah, and I think that you also like raise a generation, like all the students that went through the lab, like that really passionate about environment, and this is something else that you have to be proud of. Finally, for anyone out there who, like us, might be interested in pursuing a career in environmental engineering and research, what words of advice do you have for them?
So if you really want to be an engineer, but you really want to save Earth, then environmental engineering is what you should do. Because on one hand, of course, we're engineers, we learn about technologies, we learn about things, but we also develop technologies that have an intent to do good in the world and save Earth. And I think that this is something that that I would like to actually address. In addition to that, maybe I'll take this just to say that now our environmental engineering program is an international program. So if you are any place in the world and you want to come learn environmental engineering, then please let us know, and we'll be very happy to have you with us. Dana, maybe I would also like to say that I really enjoy that you're the ICS is part of a team. It's not advisor and student. Like, we are a team.
Definitely.
And I really enjoyed talking with you and sharing a little bit about what we do in the lab. And thanks for joining today.
Yeah, thank you, Hadas. And if someone else are interested in this kind of study, or just to come visit our lab and to see what we are doing, we are open. You can connect us, and that's going to be great. Yeah. Thank you.
Thank you very much.